Well, hello everybody and welcome to my very first very own Arduino tutorial. And for the beginning I'm starting with making an Arduino of my own. Well, that's not the Arduino actually Masimi Banzi, the founder of Arduino.cc, have made, but since this whole thing is an open source, they have released all the eagle papers and everything. And if you go through many of the tutorials in Arduino.cc in their forums or whatever place, like your instructables, your make, they have made literally many clones of this Arduino platform. Well, starting with what Arduino is, actually it's an open source microcontroller platform, and that runs on a chip from AVR that's called Atmega 328. Now AVR has got many series actually, like all the Atmega starting from Atmega 8, Atmega 16. Well, earlier I have worked on Atmega 8 and 16 onwards, but that couldn't help me a lot because they're not having any sort of open source platform, and whenever I had to work with more than 1, 2, 3 servos, I couldn't extend it because there are just some of the clock problems. Well, for the beginners who are not getting it anyways, we'll start with making a basic Arduino. Well, if you have been following my blog, you might have seen all the necessary materials to make one. Like all the off-shelf things, all you have to need is some 16 megahertz crystal, new things, and your 22 picofarad capacitors. Well, those abroad of India, these things are very not that hard to find actually, but for the place where I stay in, these things are like really very hard. Well, talking about the capacitors, I used one like 22 picofarad. What I've used in my microcontroller board was very hard to get here because picofarad capacitors are like not a jewel of my own tree. So what I did is I scraped off these things from some of my old circuit boards that I used to tip it out when I was in college. I mean, I'm still in college, but whenever I get some free time, I go to a place that's sort of junkyard for computer peripherals. You'll get printers out there, keyboards out there, UPS systems out there. So what I do is often whenever I get time, I get a screwdriver along with me, a hobby knife. I open up everything, crack up everything. I carry the whole boards along with me and I come to my place and I desolder every parts from that. So that's what I usually do as a hobby. Anyways, coming to the Arduino part. If you might have followed, this is our Arduino. See, this is the Arduino, and this is the voltage regulator. If you could see very carefully over here, this voltage regulator is LM05. I mean, it gets an output voltage of 5 volts because all the microcontrollers need an input voltage of 5 volts. If more than that, it will burn out. Just see over here, what I did is I have used one female jumper so that I can fix it just like this. And you can do one more thing to make it more compatible. You can make this voltage regulator on board along with this. You don't have to make it separate. I have made it separate for a purpose actually, so that I can use this voltage regulator apart from this microcontroller also. So there is the power rails. See these shining parts, you can see these are actually for positive VCC connections, and along the back you can see it very clearly, but if you go through the pictures of the blog, I guess you'll catch it. So this portion will be for the ground parts, and this has got I mean to say what, around 8 connections, 8 power points. So how many connections do I need for a project? Hardly 4 to 5. So this is enough for that actually. And this chip here, it's the Atmega 328 chip that comes with the actual Arduino if you have got one Arduino. But before making one Arduino, this clone of Arduino actually, I'll suggest you to buy one Arduino board at least. Well, I'm having 3 pieces of Arduino board, and for a coming project of mine I need at least 5 Arduinos actually. And the things would have been less if I had have used one Arduino Mega. It's got too many inputs and output pins rather than Arduino Uno. I guess you'd be knowing about Arduino Uno and Mega if you had been reading the blog, and if you've been following the Arduino.cc, the forums about Arduino products, various Arduino products. So this thing is basically, this video is dedicated to the tutorial, I mean introduction to what this mini microcontroller board can do actually. You can see there's a switch. Here is a switch, that's a reset switch. Now what's the function of a reset switch basically? It flushes out the buffer, stored buffer. Sometimes while burning out too many programs consecutively, one after another, microcontroller gets fed up. Oh my god, what is this? What is going inside my brain again and again and again and again? Yeah, it happens with us also. So we take a break, and this reset pin is actually the break of this microcontroller board. We just press it once and it just sweeps out everything, stored trash in its memory. And what else? Yeah, there is also an LED out here, which is connected to pin 13 by default. Actually, you can connect it to any other pin also, digital output pin also. And why I have fixed it to pin 13 is because in actual Arduino microcontroller board, they have fixed it to pin 13, and I have used here only one LED. And in actual Arduino Uno board, what I am having, and actually I am having one Uno board and two Arduino boards. Actually, Arduinos are nothing but Arduinos made cheap. I mean to say locally made Arduinos. Here Deccan Robotics, one company is there in US only, so they manufacture it. And in India we have one e-shop called Embedded Market. Guys, please note it, embeddedmarket.com. You can get free Arduinos there, just simultaneous to Arduino Domino, maybe Arduino Uno also, they're coming up shortly. So I'm having two pieces of Arduino, Arduinos and one Arduino Uno. I've used in lots of projects, experimented with a lot. I mean, these things are like quite very amazing, guys. I mean, that's so open source, so wide, and specifically about the knowledge and the IDE, I'd like to tell you. This integrated development environment that Arduino uses, it's based on processing. The whole programs are written in somewhat similar to Java language, and things are compiled in C. It's very basic actually, very easy to use. I mean to say, like, I have worked on other platforms like AVR Studios and there. So there you have to compile it, and you have, while you are burning the program to the microcontroller, that's a real mess. I've used one ready-made program burners like Kazami, and even from RoboSapiens India, there's a trainers institution, RoboSapiens India, that train you in AVRs. So they've developed one burner. They have to copy the hex file to that, and then you have to select the COM port, just like you select the COM port in Arduino IDE, similar to that. But then you have to compile it once, then all the files are created, and from there you have to select the hex file and paste it in that application, and then burn it to the EEPROM of the microcontroller. So that's a real mess. In Arduino, what you have to do, you have to just plug it in, you have to select the COM port, and then you have to compile it once done with compiling, you have to just burn it. Simple. So that's very simple on that. Plus some other simplicities about Arduino is it comes with many of the serial port, serial monitor. There you can see, whenever you are having any serial communication of Arduino with your computer, you can see the data out in the serial monitor. But for if you are having any other AVR Studios and everything, I'm not like telling that AVR Studios are bad or something. I'm just telling that for a beginner, Arduino is very good platform. Because when I started robotics, I was very afraid of this programming stuffs and everything. I used to keep myself away from programming as far as possible, and I used to inculcate myself with the technical parts and your electronics parts. Though I'm not from either of the backgrounds, I'm just a hobbyist, and I've learned mostly from tinkering, basically scrapping things out, looking at how things are going, googling it, getting helps from Tronic stuffs. There's a group, Tronic stuffs, that's very good. Plus Instructables, Make. So these things helped me a lot for gathering knowledge about these things. So that's it basically. All I wanted to show, I don't want to lengthen this lecture anymore. I mean, that's not a lecture, that's just a funny video of mine. Anyways, go make your own Arduino, gather some knowledge, study about it in forums, get your help from groups. Arduino has forum itself, you can get it from Instructables also. Make has many forums, Arduino has many forums, Google groups, I have Tronic stuff. I would like to mention Tronic stuff. Go to that, join it up. They'll help you a lot. There are lots of people out there who are making already libraries for many of the applications where you don't have to write big codes. You have to just paste in the library, write few lines, simple, and you're just gonna get your things go run. I mean, the most amazing part about robotics is an hour or two before you have dead parts lying on your table, desktop, and after 2 days or 3 days, whatever may be your project duration, these things will be moving. I mean, that's pretty amazing, guys. Well, by that, I'm not prolonging it much, but well, one thing more. I just forgot that while you are burning your program in the microcontroller, while you have burnt the bootloader, actually, you'll see your this pin 13 LED would just blink. Well, there is a already burnt blink program which comes with the bootloader, so it starts blinking as soon as you power it up after burning the bootloader. Well, I've mentioned the whole procedure of how to burn the bootloader in there, but still I'd like to mention you here once again in the tutorial, since I'm available on handy out here. So that's the LED blinking, showing you that the bootloader is completely burnt. Just a second. You see, I've told you many times that AVR ISPs, AVR boards, program burners, from where you can burn your bootloader basically to your self-made Arduino clone. Other than that, you can use your already available Arduino to burn the bootloader in your clone that you have just made. Other than that, if you're not having an Arduino, no need to worry. You just purchase one program bootloader burner. These are called AVR ISPs. These come really cheap in Indian markets, around 400 bucks, the cheapest one. Well, I've got it almost for free. I've got it from a senior college student of mine. So it give me, see, if you have followed my tutorial, there are 4 pins: MOSI, MISO, MSK, SCK and reset pins, VCC and ground. This all comes around 6 pins in total. So if you exclude VCC and ground, you have 4 pins. Now, in my board for burning the bootloader, because this is an experimental board, so it also runs as an program burner for any microcontroller. So I can snap the microcontroller from here. I can snap it out and just fix a new microcontroller, say new Atmega 328 in here, and I can stick my AVR ISP. See, I have here 4 shining pins. You see, these are 4 shining pins for MISO, MOSI, SCK and reset. These 4 pins: MISO, MOSI, SCK and reset. Well, that comes in a rhyme. You don't have to remember it. Whenever you are started working with it, it will just come into the flow, just as your as you know, the blood veins in your vessels. I mean, whatever rubbish I'm speaking. See, just look over here. Just to stick the 4 pins. See, now this comes with this socket, which is having 6 pins. Now I'm having only 4 pins. So I've made a juncture in between. This separates the 4 pins out of the 6 pins. You have to snap it in. This VCC and ground will go to the our voltage regulator part, so that while it is the USB is connected to the computer, it can draw some power from the computer itself, and it can run the microcontroller or whatever, if you are having any serial communication with the computer. So otherwise your power LED will not blink and your microcontroller will not get any power, but programs will burn definitely with these 4 pins. So then what you have to do is you have to paste, you have to stick the 2 VCC and ground pins here on the microcontroller, and these 4 burning pins to your microcontroller. Again, that MISO, MOSI, SCK stuff. After these things are done, see, this is my AVR ISP, this is my microcontroller board, this is my voltage regulator. Well, it seems a bit clumsy. Well, I'm not handy with actually I was not having a PUF board. I just used that is left in my shelf. So you can get a new power board. You can make it all on a single board, so no need to worry about that. I just explained as I made it. So go around, make your own Arduino and have fun and stay well. Bye bye.